The Yokosuka MXY7, also known as the Ohka, was a manned missile designed by the Japanese. It housed a single pilot for a one-way mission. Translated into English, Ohka means cherry blossom, but the Allies referred to it as the Baka bomb or idiot bomb. There were several versions of the Ohka, but this video focuses on the operational Model 11. The main fuselage was tubular in shape and was 19 feet, 11 inches long, with a diameter of just under 2 feet. At its core was an aluminium airframe. Longerons went the length of the aircraft, which supported fallers. Over the frame of the aircraft, aluminum sheets were fastened to create the skin of the aircraft. This gave the aircraft a very light construction. Apart from the warhead, which took up most of the weight of the aircraft, a single piece of nose cowling covered the warhead. The wings were made of an aluminium structure of spars and ribs. Attached to this was balsa wood to form the skin of the aircraft. From what we've seen in photos, this looks like it was done with a self-tapping screw. The wings were 16 feet, 10 inches wide, and had ailerons to control the roll. The Ohka's tail featured 2 vertical stabilizers. This type of design is known as a twin tail, which, as well as giving more stability and control, acted as a counterweight to the heavy nose that carried the warhead. The long nose of the aircraft was mainly taken up by the warhead. The warhead was encased in steel so as to provide the maximum armor-piercing capability upon Allied shipping. The armor-piercing warhead weighed in at 2,646 pounds, but 1,141 pounds was explosive material. The aircraft was 4,718 pounds in total. The nose warhead contained 5 fuses, 1 in the nose of the bomb and 4 in the base. The nose fuse was armed by a spinner that could be freed to spin upon release of the Ohka. The other 4 fuses were armed by the pilot. Moving to the back, the Ohka was powered by 3 Type 4 Mark I Model 20 rocket engines. A solid rocket engine works by burning solid propellant to produce high pressure and high temperature gases, which are then expelled out of a nozzle at the back of the rocket to produce thrust. The basic components of the solid rocket engine are the casing. This is the outer shell or body of the rocket engine that holds everything together. It has to be very strong, enough to withstand the high pressures generated from inside the engine. The nozzle. This is the opening at the back of the rocket where the gases are expelled out. The nozzle is designed to accelerate the gases and expel them at high speed, generating thrust. And solid propellant. This is the fuel and oxidizer mixed together in a solid form. The fuel is what burns, and the oxidizer is a chemical that provides the oxygen needed for the fuel to combust. The propellant is packed into the casing in a cylindrical shape with a hole running down the middle, known as the core. According to US scientists that analyzed the Ohka, the chemical analysis of the propellant was 59.9% nitrocellulose, 26.9% nitroglycerin, and 6.1% mononitronaphthalene, 2.9% ethyl centralite, and 1.3% volatiles. The engine output was 588 pound-feet of thrust. In each of the three Ohka's engines were 6 tubes of propellant. They were arranged in 3 groups of 2, effectively making 3 long tubes of propellant. The motor was lit using a small igniter that was placed at the end of the engine, furthest from the nozzle. It was activated by the pilot by means of an electrical signal. When the igniter was lit, a very fast-burning material that produced hot gases and particles was expelled into the core of each of the 3 tubes of propellant in the motor. These hot gases and particles ideally ignited the inside of the surfaces of the 6 sticks of solid propellant evenly along the length of the engine, initiating the combustion process. Let's go through the inside of the cockpit. First, there was a red switch that would be set to arm 4 of the 5 fuses on the warhead. Then, the rocket selector switch. This would allow the pilot to select which rocket motor would be activated when pressing a button on the joystick. The switch would usually have 5 settings: off, 1, 2, and 3 for the main rockets, and another setting for some models of Ohka that had underwing rockets for extra range. The intercommunication switch was for sending and receiving Morse code to the carrying Betty. There was also a compass. An altimeter showed the height to sea level and worked through an air pressure sensor. The airspeed indicator used a pitot tube located on the left wing to determine the airspeed. There was also a turn and flip indicator that used a gimbal-mounted gyro. The turn and slip indicator is a flight instrument that was used to understand the orientation and movement of the aircraft in the horizontal plane. It consisted of 2 components, a turn indicator and a slip indicator. The turn indicator shows the rate at which the aircraft is turning. It indicates whether the aircraft is in a coordinated turn without any side slipping or skidding. The slip indicator, when centered, shows the aircraft is in coordinated flight. If it moves to one side, it indicates a slip or a skid. Together, these 2 indicators help the pilot maintain coordinated flight during turns. Then there was an inclinometer that indicated the vertical angle of flight. The inclinometer used in Ohkas was a Model 2 manufactured by Tokyo Koku Keiki Feisakusho. It differs from a standard inclinometer by having a modified scale, placing the 0 mark near the top to better indicate steeper dive angles. The circuit test switch activated the aircraft electrical systems. The red light signaled the activation of the electrical circuit. The pilot's controls consisted of a joystick and a rudder. The joystick, when moved left and right, moved the ailerons on the wings, which controlled the roll of the aircraft. When pushed forward or pulled back, it moved the elevator in the tail and controlled the pitch of the aircraft. On the joystick was also a button to activate the rocket that was currently selected on the rocket selector dial. The rudder control wasn't pedals, but was more rudimentary as a bar that pivoted upon its center. This activated the 2 rudder control surfaces on the tail and controlled the yaw of the aircraft. These simple solid rocket motors could not be shut off once they were lit. The rockets would propel the Ohka to a top speed of up to 400 miles per hour in level flight and 580 miles per hour in a dive. The rocket had a burning time of just 8 to 10 seconds, which meant very short range. Contrary to most depictions of the Ohka in games and in art, the engines were not designed to be fired simultaneously. Instead, to maximize range, the pilot had a control dial, which could be rotated, and then a button pushed to fire one rocket at a time. We'll take you through that later on. In order to get the Ohka in position, it was carried underneath a Mitsubishi G4M2E Betty bomber. The maximum range of the Ohka depended upon the height it was released. Typically, the range was about 35 times the release height. However, they could be released at 10,000 feet, and this would give a range of about 18 miles. Some 50 miles from the target, having said a formal farewell to the bomber's crew, the pilot crawled through the bomb bay and into the cockpit of the Ohka. The first thing the pilot would do is buckle up. Then, on the floor, at the 8 o'clock and 4 o'clock positions were bungee cords secured to the footbar, which were removed by the pilot. The bungee cords prevented the rudder from being activated while the Ohka was being carried by the Betty bomber. The pilot would also remove a pair of thin metal rods attached to the joystick at the 10 o'clock and 2 o'clock positions. The cables and rods were always handed up to an assistant in the bomber as a safety measure, because if left inside the cockpit, they might jam the controls or fly around and injure the pilot. There was a fifth restraining device. There was a combination of a metal rod with an eye hook attached to a spring on the joystick. It stayed connected to prevent the pilot from pulling back on the joystick at the moment of release, which could cause the Ohka to lurch up and strike the Betty. The pilot would then reach over his head to pull a little wooden block until the canopy slid forward and snapped shut. He would then switch the engines to standby and activate the fuse handle, arming the warhead. He would take a padded earpiece. Once all was ready, he would announce into the mouthpiece, "Seibi Junbi Yaroshi," while pressing the button of the instrument panel to tap out the Morse code symbol for "Say," the Morse abbreviation of his message. A flashing light and a buzzer gave him visual and audio confirmation of his Morse code message. The Betty pilot pulled the lever. The hook would release from the hoist point, and the Ohka would drift away from the Betty. The point of no return. The Ohka's flight began with a shallow, unpowered glide, reaching a speed of 230 to 280 miles per hour. The spinner can now move freely. A cotter pin prevented the spinner from moving while it was attached to the aircraft. The warhead would now be fully armed. The pilot had a dial to select a rocket and then push the button on the joystick to light the rocket. When the rocket was lit, the pilot would experience instant acceleration. When one rocket was burnt out, he would select the next one, and so on. Standard operating procedure was to leave one rocket until the final part of the Ohka's approach to an enemy vessel. But the weight of the other two rockets already expended, the final rocket would be where the Ohka reached maximum speed. Having lined the target on the enemy vessel, the Ohka would impact above the waterline. Instantly, the wooden and steel structure would disintegrate, leaving the armor-piercing warhead to push through the side of the vessel before detonating from within. We used many sources to get as much information as we can for this film. Please let us know in the comments where we got information incorrect. We're looking forward to as much dialogue as we can get with these films. Thank you.